First, we have diatomic molecules. A molecule consisting of only two atoms of the same or different elements are called diatomic molecules. An example would be carbon monoxide, which is CO. Polyatomic molecules are a molecule consisting of more than two of the same or different elements, such as perhaps ammonia, NH3. So the covalent bond is the attractive force between the two atoms that results when the electrons are shared by the atoms. And that's a type of chemical bond. Here is an example. What happens when two nonmetals bond? Well, they will form a covalent bond. A covalent bond occurs when two atoms share electrons to become a molecule. A covalent bond arises then from the simultaneous attraction of the two nuclei for the shared pair of electrons. The Lewis structure is a way of allowing us to illustrate or to show covalent bonding. It will allow us to use a dash to show the sharing of electrons. For example, chlorine plus chlorine, and you'll notice that each one needs an electron. So it will now share, and it will show that share with the dash. The dash represents a covalent bond. Another term we want to take a look at is the term bonding capacity. The term bonding capacity refers to the number of electrons lost, gained, or shared by an atom when it bonds chemically. It gives you an idea of how many electrons that particular element has available. So here's a table of some of the more common ones. So if we take a look at carbon, and on your periodic table you will see that the number of valence electrons is 4. So that means the number of bonding electrons, how many more to get to 8, would be 4. So its bonding capacity is 4. Nitrogen is 5 on your periodic table, which means that it has 3 bonding electrons. 5 plus 3 is 8. So its bonding capacity is 3. Oxygen is 6 for the number of valence electrons it has, which gives us 2 bonding electrons, giving us a bonding capacity of 2. The halogens, which are right next to the last row, the stable gases, is 7. It can gain 1, so its bonding capacity is 1. And hydrogen is 1, bonding capacity 1, and electrons 1. Hydrogen is in row 1, which can only have at the most 2 electrons. Now that brings us then to talk about polyatomic ions. So a covalently bonded group of atoms with an overall charge could occur, and a polyatomic ion can contain a combination of covalent and ionic bonding. So an example is ammonium chloride, NH4Cl. Now, if you were to examine this, its properties would be it's a white crystalline solid. It dissolves rapidly in water and is an electrolyte, which means it can dissociate to form a cation or cation and an anion. Its composition, it contains a chloride ion, Cl negative, and an NH4 plus ion held together by an ionic bond. So NH4 plus are held together by a covalent bond. So other examples, SO4 2 negative is sulfate, CO3 2 negative is carbonate. They're covalently bonded groups of atoms carrying an overall charge. Another term, the coordinate covalent bonds. Molecules are composed of two or more different elements, can sometimes form covalent bonds where both of the electrons making up the bond are provided by the same atom. This type of bond is a coordinate covalent bond. For example, consider the formation of the ammonium ion from a regular covalent molecule, ammonia, which is NH3, with a hydrogen ion, H+. The hydrogen ion does not bring any electrons with it. So to achieve a complete outer shell for hydrogen, it can borrow 2 electrons from the atom with which it bonds. Let's see what this would look like. So let's use NH3 as our example to illustrate coordinate covalent bonding. We're going to start by drawing the Lewis structure for ammonia. To do this, we're going to arrange the atoms with nitrogen, which we saw in our previous table, has the highest bonding capacity. We're going to put it at the center, and we're going to then show the 5 valence electrons, and then the 1 valence electron from each of the 3 hydrogen atoms. Okay, so there's nitrogen with the 5, the 3 hydrogen. Okay, now show the pairs of shared electrons or covalent bonds between the adjacent nitrogen and hydrogen atoms as dashes. You will see the nitrogen still has 1 lone pair and 3 bonded pair with hydrogen. Now, using an example of NH3, let's take a closer look at coordinate covalent bonds. First, we're going to draw the Lewis structure for ammonia. To do this, you're going to have 1 lone pair at the top of nitrogen. Remember, nitrogen has 5 electrons, so 2 at the top, and then 1 to share with hydrogen. They'll both share 1 electron at the left side, right side, and bottom. So the resulting diagram shows there is one lone pair in this structure. Now, we're going to take a hydrogen ion that has no electron on its own, so it's showing now as an H+, and it's going to bond with the ammonia molecule by sharing this unbonded pair of electrons. So it's getting its electron from the nitrogen. So what we have then is a hydrogen, nitrogen, hydrogen, 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 4 hydrogen, 1 nitrogen, and we're left with a plus charge, which means that this would be an ion. The plus side outside the bracket indicates that the positive charge is not really associated with any particular hydrogen atom. Now that we have looked at the bonding of ions, atoms with covalent bonds, what are the properties? Covalent bonds are strong. That means a large amount of energy is required to separate the atoms making up the molecules. This provides some interesting properties. Covalent molecules tend to be stable at relatively high temperatures. They do not decompose upon heating. The strength of the bond increases as the number of electron pairs in the bond increases. Triple bonds are stronger than double bonds, and double bonds are stronger than single bonds. Now, let's put this information from the slideshow into practice. In our next video, we'll take a look at how to draw Lewis structures and structural formulas for molecular compounds.